Hello friends, I am from Chemistry faculty of QLS Academy. Carbon compounds are deeply rooted in our lives. हम कोई भी चीज़ यूज़ करें carbon present होता ही है. So today we are going to learn about some important carbon compounds. Hope you will enjoy today's class. So now let's get started. We know that there are over 3 billion carbon compounds known to us. There are so many and so diverse carbon compounds that a whole new branch of chemistry had to be established, specially dedicated to carbon compounds only. Carbon compounds were initially extracted from natural substances, and hence it was thought that these compounds could only be formed within a living system. So scientists started calling them organic compounds, and today carbon compounds are studied under organic chemistry. But this conception that vital force is necessary for the synthesis of carbon compounds was disproved by Friedrich Wöhler in 1828 by preparing urea from ammonium cyanate. Since then, carbon compounds, except for oxides of carbon, carbonate and hydrogen carbonate salts, are continued to be studied under organic chemistry. So today we are going to talk about a few such commercially important carbon compounds: an alcohol and a carboxylic acid, and soaps and detergent. First, let's talk about alcohol. Out of all alcohols, methanol, ethanol, propanol, butanol, ethanol is the far most important one. कॉमन लाइफ में हम जब भी अल्कोहल की बात करते हैं, वी एक्चुअली मीन इथेनॉल. Ethanol is the active ingredient of all alcoholic beverages. Its consumption causes drunkenness and can cause serious health problems with long-term consumption. Though ethanol is consumed in beverage, pure ethanol should never be consumed as a small amount of absolute ethanol can be lethal. Alcoholic beverages में सिर्फ ethanol नहीं होता, उसके साथ दूसरे ingredients भी mix होते हैं. So, alcoholic beverages में ethanol is just an ingredient. Ethanol is also a good solvent, and hence it is used in preparation of many medicines such as tincture of iodine, cough syrups and many other tonics. At room temperature, ethanol is a colorless flammable liquid. It has a boiling point of 78 degrees centigrade and melting point of minus 114 degrees centigrade. In your chemistry labs, you may have seen bottles of alcohol labeled as denatured alcohol or denatured ethanol. Denatured ethanol is pure ethanol containing a small amount of methanol and sometimes a blue or pink dye. It is done to stop the misuse of industrial grade ethanol for drinking purposes. Ethanol in its purest form is lethal, but methanol and another form of alcohol is poisonous in any form or any concentration. On consumption, methanol is oxidized to methanol in liver. Methanol को consume करने के बाद in liver, methanol methanol में convert हो जाता है. Methanol then reacts rapidly with the components of cells and coagulate the protoplasm of the cells. Methanol also affects the optic nerve, causing blindness. So methanol पीने से आपकी liver और दूसरे cells तो damage होते हैं, आप completely blind भी हो सकते हैं. Nowadays, ethanol is also being used as a fuel. It is because ethanol, if combust, do not produce any harmful air pollutant. It just releases carbon dioxide and water. Now, let's see some chemical properties of ethanol. First, reaction of ethanol with sodium metal. Reaction of ethanol with sodium metal is similar to the reaction of metals with acids and bases. जैसे metals, acid and bases के साथ react करने के बाद metal, salt and hydrogen gas produce करते हैं. Similarly, ethanol on reacting with sodium produces sodium ethoxide and hydrogen gas. Now, let's see how ethanol reacts with acids. When ethanol is heated at 170 degrees centigrade with excess of concentrated sulfuric acid, it results in the dehydration of ethanol to produce ethene. So, concentrated sulfuric acid के साथ जब हम 170 डिग्री पे ethanol को heat करेंगे, it will convert into the unsaturated hydrocarbon ethene. Now, we are going to talk about a carboxylic acid, ethanoic acid. Ethanoic acid is commonly known as acetic acid. As the name itself suggests, it is an acid, but it belongs to the group of weak acid. Ethanoic acid एक acid तो है, but एक weak acid है. A diluted acetic acid, nearly 5 to 8% solution of acetic acid in water, is known as vinegar. Vinegar is used in many food items for flavoring and also as a preservative. Ethanoic acid is a colorless liquid with a pungent smell. It has a melting point of 17 degrees centigrade means at temperature lower than 17 degree centigrade it will start to freeze. 17 degree के नीचे आते ही temperature acetic acid जमना start हो जाएगा. Hence, it is also called as glacial acetic acid due to its hazy, icy appearance at low temperatures. Now, let's talk about the chemical properties of ethanoic acid. Since it is an acid, it will obviously react with a base to give out salt and water. Acid has to obviously neutralization reaction तो करेगा ही. Ethanoic acid is a weak acid, so on reacting with a strong base like sodium hydroxide, it will form a basic salt. Ethanoic acid on reacting with sodium hydroxide gives out sodium acetate, also known as sodium ethanoate, and water, just like any other neutralization reaction. In a similar way, ethanoic acid also reacts with other basic substances like carbonates and hydrogen carbonates. Ethanoic acid reacts with carbonates and hydrogen carbonates to give rise to salt, carbon dioxide gas, and water. On reacting with sodium carbonate, it gives out sodium acetate salt, carbon dioxide gas, and water. And the same products are formed when ethanoic acid reacts with sodium hydrogen carbonate. These were normal acid-base reactions. Ethanoic acid is used to make another class of carbon compounds known as ester. Esters are sweet-smelling substances used in making perfumes and flavoring agents. Esters are produced when a carboxylic acid reacts with an alcohol in presence of an acid catalyst. So esters कब produce होते हैं? जब एक carboxylic acid और एक alcohol आपस में react करते हैं in presence of an acid catalyst. Ethanoic acid, when reacts with absolute ethanol in presence of an acid catalyst, it gives out ester, ethyl acetate. जब acetic acid ethanol से react करेगा, or we can say ethanoic acid ethanol से react करेगा, it will give out ethyl acetate, ester. Notice that the arrow between the reactants and the products is a two-way arrow. ये arrow दोनों तरफ जा रहा है. Reactant से product की तरफ आ रहा है, product से reactant की तरफ भी जा रहा है. It means that the reaction is reversible. ये reaction दोनों ही direction में move कर सकता है. Ester किसी acid और base की presence में वापस carboxylic acid and alcohol में convert हो सकता है. This reverse reaction is favored more by bases. Esterification में हम किसी acid catalyst का use कर रहे थे. So the reverse reaction is favored more by bases. अगर उसे reverse में जाना है, which is favored more by bases. So the reverse reaction is favored more by bases. That's why during preparation of esters, acid catalyst is used, which majorly gives ester with a small amount of carboxylic acid. This reverse reaction is known as saponification because it is used in the preparation of soaps. So ester, ethyl acetate, reacts in presence of sodium hydroxide to form ethanoic acid and ethanol. So these were the 2 out of millions of important carbon compounds. Esters are hydrolyzed in alkaline conditions to form soap. Now let's learn a little about soaps. Soaps are sodium or potassium salts of long chain carboxylic acids. The two ends of soap, the ionic end with sodium or potassium ions and the long hydrocarbon tail, have different properties. End with sodium or potassium is hydrophilic, means water loving. It interacts or dissolves in water. While the other end, long hydrocarbon tail, is hydrophobic, means it hates water, means water hating. It dissolves in hydrocarbons only. Soaps are used for cleaning purposes, to clean dirt, and most dirt is oily in nature. And it is a well-known fact that oil never dissolves in water. Oil कभी भी water में mix नहीं होता है. Doesn't matter how hard we try, oil and water will never mix. They always separate out in distinct layers even after the most vigorous shaking. Oil is hydrophobic, just like the hydrocarbon tail of soaps. And it is another fact that like dissolves like. Hydrophobic substances will dissolve in hydrophobic solvents, while hydrophilic substances will dissolve in water and other hydrophilic solvents only. The ionic end of soap dissolves in water while the carbon chain dissolves in oil, the dirt. Then the soap molecules form structure called as micelles, where the hydrocarbon tail of the molecules is oriented towards the oil droplet and the ionic end faces outside towards water. This forms an emulsion of dirt in water and thus helps in dissolving the dirt in water, which can be washed away from our clothes. So here you can see there are many molecules of soap, and on coming in contact of the dirt, or we can say the oil, the The hydrocarbon tails interact with the dirt and start to trapping inside a missile. The ionic end, the sodium or potassium ions, interacts with water and forms a round molecule known as missile. Molecules of soap interact with dirt, traps it inside the missile. The missile stays suspended in the solution as a colloid and do not interact with each other to come together and precipitate out because of the ion-ion repulsion. मिसल्स एक दूसरे को रिपेल करते हैं, इसलिए वो कभी भी साथ में आके प्रेसिपिटेट आउट नहीं होते हैं. They remain suspended. So the dirt is suspended in the missile easily and gets rinsed away. The soap missiles are very large enough to scatter light. Remember Tyndall effect? The scattering of light when it passes through a colloid. So soap water is an emulsion, and emulsion is a type of colloid. So soap water is capable of showing Tyndall effect. Soaps usually form lather, but sometimes it doesn't. Soap can't lather in hard water. Water containing salts of calcium and magnesium is termed as hard water. Soap molecules react with calcium and magnesium salts to form an insoluble precipitate known as scum. A large amount of soap will be required if hard water is used, and at the same time, the cleansing property will be less effective than before. This problem is overcome by using another class of cleaning agent known as detergents. Detergents have a similar structures as soaps, just that they have ammonium or sulfonate salts of long-chain carboxylic acids instead of sodium or potassium salts of long-chain carboxylic acids. These charged ends of detergent do not react with the calcium and magnesium ions in hard water to form the insoluble precipitate. Thus, detergents remain effective in hard water and provides with the better cleaning than soaps. Detergents are usually used to make shampoos and cleaning agents for cleaning clothes. So friends, this was all for carbon and its compounds. Today we learned about a few carbon compounds, ethanol, ethanoic acid, soaps and detergent, and also about a new class of carbon compounds, ester. We also learned about some important chemical reactions, hydrogenation and esterification. In next class, we will start with a new chapter. Till then, if you have any doubt or need any information, you can visit the following link.